This is lesson 6.4b in elementary algebra, continuing on with equations involving rational expressions. We are on example 5, and we're solving this equation right here. Okay, so we have to find common denominator. Alright, so again, when we have a denominator like this, this and this are the only things that we have that we're missing in different places. So the common denominator is obviously going to be 2 times the x minus 3, or this x minus 3. Because if I looked and said, alright, what am I missing here? Well, I'm missing a 2. So we put it there, and we put it there. And what am I missing here? I'm missing an x minus 3. And you can go through that whole thing, which is nothing wrong with it. But you should be able to get to the point where you're looking at this and say, I know my common denominator is going to be each one of my different denominators. So since these two are the same, they aren't different, obviously. So this times this is my common denominator. So 2 times x minus 3 times and then my common denominator again, and then my common denominator again. Oh, come on, pen, right. Okay, then I cancel that with that. Notice my denominators always cancel. That's all that does. It just gets rid of the fraction. So I've got those two. Now I've got 3 times x minus 3, multiplying those, equals 2 times 3 is 6. So let's go ahead and distribute. Add those. Add 9. Divide by 5. And x then equals 3. And that's what I wanted there for an answer. Alright. Now, this is where it gets a little bit tricky, and one of the things that I have not been doing that I should do, and I'm showing you this now to show you the importance, is x equals 3. So what should happen is I should be able to pull it back and put it in this original equation and have this give me a true statement. Okay, well, let's see what happens here. Well, first of all, let's see if I can erase some of this without erasing all of it. Let's see here. So we got x equals 3, didn't we? Well, let's put it in here. Okay, what I'm going to look at is that and that. What is 3 over 3 minus 3? Alright, whenever you get a 0 in a denominator, it makes the whole stinking thing undefined. There is no answer. 3 works for x, but when you plug it back in, it doesn't work. So this is the solution set. It's called the empty set or the null set. It's not 0, it's not any number, it means the answer does not exist. So that's why you go back and check these, is to find out if the answer exists. And in this last one, we're going to run into one that's very similar to that, just to remind you that you need to do that checking. Alright, so example 6. A plus 4, and that is over a squared plus 5a, and that equals negative 2 over a squared minus 25. Alright, well, let's see what we've got here. A plus 4 over, we're going to factor out an a, and that equals minus 2 over, and this is the difference of two squares. Okay, so it looks like that. So common denominators. Common denominators would be all the different parts multiplied together. Okay, so if I took all that I circled times this whole stinking thing, so let's take it first of all times that, and then I take it again and do it in blue. Okay, so we have a times a plus 5 times a minus 5 times negative 2 over okay, let's cancel these two with these two, this one with this one, this one with this one, and I have an a minus 5 times a plus 4 equals negative 2a. This a and that negative 2. Alright, so then I go ahead and multiply, and I get a squared. I do the FOIL, and I get that when I multiply those out. Okay, let's move everything up a little bit. Okay, move everything else out of the way first. Okay, let's set it equal to 0. So we're going to add 2a here and 2a there. And I get that. Okay, so that doesn't look too bad. Make two parentheses, put an a there and an a there. Two numbers multiplied give me 20, added give me a 1. So that's going to be a 4 and a 5, because the difference between those is 1. That's going to be my positive, and I get that for an answer. Okay, so I'm happy with that for an answer. A then is either 4 or negative 5. So let's go ahead and check that by putting it in the original problem. And what you'll do is you'll put negative 5 in first. So let's move this up so we can see what happens here. I'm going to write the original problem again. Ugh. Okay, so let's put 4 in there first. So we have a choice of 4 and negative 5. So if we put 4 in there, we get 4 plus 4 over 16 plus 20 equals negative 2 over 4 times 4 is 16 minus 25. Alright, so that gives me 8 over 36. This gives me negative 2 over 16 minus 25 would be 9. This reduce, negative 9, so positive, since two negatives give me a positive. 8 over 36 reduces to 2 ninths. Those work. Alright, so 4 is a good answer there. For some reason my stuff won't erase, so we'll do it in red. So now I'm going to use the same equation but put the negative 5 in. Negative 5 times negative 5 is 25. 5 times negative 5 is negative 25. 5 times 5 is 25 minus 25. And look what we got again. We got zeros on the bottom. So because we got zeros on the bottom, it's undefined, or it's the null set. So 5 does not work. Make it go away. 4 is the only number that works there. Okay, so that is lesson number 6.5. And the key thing for, or 6.4, the key thing for 6.4 is finding those common denominators and multiplying the whole stinking thing by the common denominator so that you can get rid of your fractions. Alright? Now there's all kinds of other ways to do this, but that's the key thing that you're trying to do, is get rid of your fractions. So let's look at number 40 real quick. I'm not going to do the whole thing, I just want you to look at it. Okay, the key thing you're going to do is you're going to look at that one first and see if you can break it down into two binomials. Two numbers multiplied that give you 8, added give you 6. So negative and negative, because negative 4 times negative 2 is going to give you a positive 8. Negative 4 plus negative 2 is a negative 6. Okay, and then you've got your x minus 2 here, and x minus 4 there. Alright, so that is your common denominator because it already contains both of those. So you're going to take this whole thing here and you're going to put it in front and multiply the whole thing by that. And when you do that, in fact, what you're going to do is you're going to replace this with the x minus 4 and the x minus 2 here. So this isn't really going to be there. This is going to be there in place. And things will start canceling. All of your denominators will cancel, and then you go ahead and solve for your x. And in this particular one, you're going to get an x equals negative 1 and an x equals negative 3, and then you're going to have to plug them in to the original equation right here to see if it actually works, because you can't get a 0 in the denominator. Okay? So that's about all I can do for you. It's just practice, 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 and make mistakes and have a hard time and yell and scream and cuss and cry, but it'll start coming. Alright, so that is problem set 6.4.